Alright, so we are on lesson 5-1, Basic Antiderivatives. Today we have been cursed by the crazy cat lady, which means we must end all sentences with the word meow. Alright, so...
That was the end of the sentence. Yeah.
And I ended it with meow by saying the word meow to end my sentence. So it still counts if I end my sentence with meow. Ta-da! Meow.
I'm just kidding.
Yes, someone read our objective, please meow.
Go ahead.
No, go ahead, you meow.
Find the antiderivative of simple general and simple powerhouse functions. Well,
by the way, today's date is Wednesday, November 13th, meow. Yeah, so we're doing antiderivatives. That's this entire unit, meow. We're going backwards, meow. Derivatives are going forwards, meow. Antiderivatives are going backwards, meow. So, yeah, if you've done, this is my third time doing it now, meow, so it's not that hard, meow. Basic derivatives and antiderivatives. So if we start with, let's talk about our powerhouse, right, meow? Powerhouse, we have two things that we do, meow. And if you need some reference, you can write it off to this left-hand side, meow. X squared, meow. What do I do with the 2, meow?
it goes to the front, meow.
You multiply it down, right, meow?
Yeah.
All right, so we write that down, meow. Multiply down, meow. That was the first step, meow. What was the second step after you bring that 2 down in front, meow?
The exponent goes down to power, meow.
Exactly. So I'm going to just say subtract 1, meow, and we'll know what that means, right? Subtract 1, meow. Okay, so now we need to go backwards, meow. So instead of, we're gonna go backwards in terms of the steps and backwards in terms of the operations, meow. So inverse operations, and we're starting with step 2, meow. So instead of subtracting 1, we are now going to do what, meow?
Add 1.
There it is, meow. Add 1, meow. And we're talking about the exponent, of course, here still, meow. And then next step is to do what, meow?
Divide down.
Yeah, well, I guess it's still kind of dividing down, meow. So I'm going to say divide down. I know that you want to reverse each of these words, but if you reverse everything, then you can get double negatives and you haven't reversed it. So I'm going to say divide down, meow. All right, and you might be asking me the question, Mr. Sindel, there were 2 steps for derivatives and 3 steps for
You
antiderivatives,
multiply
so
up.
what is the final third step, meow? An arrow knows this, meow.
You multiply up.
Something to do with C.
It is, yeah, meow. And I'm going to write this in red because it is the most commonly forgotten step is to add C. Meow. That C has a very specific name that you don't need to have memorized, but I am going to be referring to it a lot, so it is helpful to have it written down, meow. It is called the constant of integration, meow. Again, I love saying K stands for constant, but in this case it actually makes sense. C stands for constant, meow. So let's see an example of this, meow. Let's take the derivative, just doing the stuff that we had over here, meow, and then we will take the antiderivative over here, meow. And this S right here, that is, you just read that as the integral. So, meow, integral, meow, integral, this thing right here, meow. Technically, it's the integral. For now, we're calling it the antiderivative. Later, we'll be calling it integral and definite integral and stuff like that, meow. But that's how I pronounce that, meow.
Wasn't there a reason it was S-shaped, meow?
Yes, you're technically finding the sum of all of the infinite number of rectangles that are underneath the curve that you're finding, meow. I will talk about that a little bit more. Is it tomorrow? I have the notes in front of me. I thought I did.
This is the one I had to teach, meow.
Oh, yeah. So I have those notes somewhere, meow. Oh yeah, it is tomorrow, meow. Anyway, if I take the derivative of 5x squared, I get what, meow?
10x.
10x, meow. Oh, and look, I'm going to now go backwards, meow. So if I'm going backwards, meow, I'm going to add 1 to the power, meow. So it now becomes 10x to the power of, shout it out, meow? 2, meow. And then from there, I'm going to do what, meow?
Divide down.
By what, meow?
2.
By 2, meow.
5.
Divide down by whatever I just had, meow, which is 2, meow. And don't forget your, what do I call that thing? You can call it C or the, what, meow?
Constant of integration.
There it is. So I'm going to go ahead and say plus C as well, meow. And I can, of course, simplify this thing, meow. This turns into just 5x squared plus C, meow. And that is my final answer, and I can box that, meow.
When do you explain why we need C?
Why do we have the plus C?
That is a great question. I will address it now, meow. So let's assume that we are actually taking the derivative of 5x squared plus 10, meow. What is the derivative of 5x squared plus 10, meow?
10x.
What is the derivative of 5x squared minus 1,000, meow?
10x.
We don't know what this constant was, so we just write C, letting you know, hey, there's probably a value there. It might be 0, but at least we account for the fact that there might have been something there, meow.
Weird.
I have squared 1.
Yeah.
I'm loving the love that is happening right now, meow. All right, so let's go ahead and practice rewriting some forms, and then we can actually take some. Oh yeah, there's just like lots of tiny little practice here. Tomorrow's going to be a little bit of harder of a day because, meow, we have just simple powerhouse and simple general functions. Tomorrow we will have complex general and complex powerhouse, which you will need taxman for, meow. So I think tomorrow's our taxman day, meow.
Do taxes.
Yeah, we're going to pay our taxes, meow. Again, it's one of those cutesy things that John Wynn invented that makes it super easy for you guys to Are you eating food in my classroom, meow? How dare you, meow?
People watch
I bet someone's like at their laptop right now and like, I'm sorry, meow. Anyway, here we go, meow. Let's go ahead and rewrite this integral, meow. This is now going to be the integral or the antiderivative. You can pronounce it either way for now, meow. The antiderivative of what, meow? Rewrite this square root of x as
Negative 2x to the
Negative
X to the 1
negative
half.
x.
Wait, x to the 1 half.
the 1/2,
Yeah.
meow. Yep. All right, and we also need to rewrite this dx, meow. And I don't really want to explain that now. Tomorrow, there's a future lesson that explains it a little bit more. I never really go that in depth with why we write dx right there, but it is important, and you are going to get things incorrect, at least on the free response, if you don't write it for now, meow. Whenever you're going backwards, you need to have that d of x. Before I take the integral, whenever I actually go backwards, then the d of x disappears, meow. Yeah, again, you'll be confused for now. It will make sense a little bit later. Yeah. So now that we have our rewritten form, let's go ahead and take the antiderivative now, meow. So, step number 1, meow.
Divide. Wait. No. Add 1.
Add 1, meow. So that becomes, instead of 1/2, it becomes what fraction, meow? Not mixed fraction. I want an improper fraction, please, meow.
1/3.
3/2, meow. So I now have negative 2 to the power of, x to the power of 3/2, meow. And again, just on the side notes, if you don't know, 1/2 plus 1, meow, is the same thing as 1/2 plus 2 over 2, meow, which is 1 plus 2 is 3, meow. 2 plus 2, well, you stay the same. 3 over 2, meow. Question, Gio, go.
Never mind.
Yeah.
You just answered it.
Ah, perfect. I anticipated the question, meow. All right, so we added to the power, meow. Second step is to do what, meow?
Don't forget your dx.
Well, now we're taking the antiderivative right now, meow, so we don't need the d of x anymore. You only need the d of x when you're rewriting the forms, meow.
If you notice, the integral symbol has disappeared as well.
Yeah, if the integral disappears, the d of x disappears, meow. That's a good way to remember it, meow. Okay, we have still to do step 2. Repeat again.
Divide by
Yeah.
the-
Well, constant of integration is step 3. Divide down, meow, which is kind of hard, right? Don't write this down. This is the long way of doing it. This is the boring, long way, horrible way of saying, okay, I'm going to divide by 3/2, meow, right? Which is correct, but I'm going to keep, change, flip it, right? So I'm really going to be multiplying by 2/3. I'm going to put that out front. 2/3, meow. So, yes, again, you already are a step ahead of me, Stego. Stego, can you please tell me my final answer after I simplify everything, meow? Let's see. There it is. Thank you, meow.
Wait, how did you know the 2/3 again?
So, again, it was a keep it, change it, flip it, meow. So this was, so technically I have to divide by 3/2. I have to divide down, meow.
Oh, okay.
So
yeah,
divide by 3/2. I'm still going to explain it just in case anyone else has a question. That's going to be a keep, change it, flip it. So it's changing to multiplication here, meow. And it turns into 2/3, meow. Good question, Gio. I like those questions. So far, so good, meow?
Yes.
Yeah.
Meow. All right, anyway, we're going on to the quotient, meow.
Yes from now on.
Yeah. I don't know about that.
I'm going to rewrite this, so I'm going to leave the integral. I'm going to leave the d of x, meow. So this is now going to be the antiderivative, or the integral, however you want to pronounce this thing, meow, of what? I need to change this form into a non-fraction, meow.
To -2.
3 times x to the -2, meow, dx, meow. All right, we've changed the form. Whoo, meow. Time to actually take the antiderivative now, meow. Do that, please, meow. I'm going to do what to the power? So it's going to, yes, -1, meow. And then I'm going to do what, meow?
Divide by
down.
-1.
Exactly. When I divide by -1, that's the same thing as multiplying by -1, which is just,
-3x to the negative power plus c.
exactly, meow. Let's go ahead and rewrite the form into a positive power, please, meow. And that's going to become what, meow? I can change this all to yellow, meow. Oop, not that.
-3 divided by x. And then plus c.
It is indeed, meow. So I have -3 on the top, meow. That x goes to the bottom, meow. And I have that constant of integration for -3 divided by x plus c for my final answer, meow.
I hate when I do those. The combo one?
Oh, yeah. When you have a square root and a fraction, meow.
Yeah, I hate those ones.
Yeah, they're difficult, but the more you practice, the better you'll get. So
Wait,
here
is
we...
it -1x to the power of -1/2.
-1/2. You have it indeed correct. dx, take the antiderivative out front. You have correctly rewritten the form. Yeah.
This is -1/2.
It is -1/2 because it, again, if you want to do this in steps, I can do it off to the left-hand side here, meow. I just need some more room here, meow. And that doesn't count. Yeah, that does count, meow. If I have this thing, I can rewrite -1 over the square root of x, meow. First step is to just change this to -1 over x to the 1/2, meow. And then from there, I switch this to come up to -1 x to the power of -1/2. And I did kind of squeeze that in there, but I think that's fine for you guys, meow. Yeah, but you got it correct, Gio. So now I need to take the antiderivative. I need to go backwards, meow. Someone do that for me, please, meow.
So it's -1x to the power of 3.
Be careful, meow.
-3.
So I'm going to do some scratch work off to the side, meow. -1/2 plus 1 is the same thing as -1/2 plus 2 over 2, meow. And then it's going to be what?
1/2.
Exactly. This is going to be 1/2 here, meow. And step number 2, meow.
Why are you writing at the 1? Yeah. In front of the x?
Yeah, you don't need to have that coefficient there, meow. It could just be negative, meow. It is a little bit quicker and more efficient. But we can still do that. It's still mathematically correct. And what are we going to do next, meow?
Divide down.
Divide down, which means we are really, again, you're not writing this down, meow. You're really dividing by 1/2. I mean, you can write this in your notes if you want. But, meow, we need to keep, change, flip it. Change it to a multiplication and flip this, so I'm really multiplying by 2, meow. And you can do that out front, behind, it doesn't really matter. I'm going to do it out front because that's normally where the coefficients live, meow. And our final answer is what, meow?
-2.
-2 square root of x plus c. Thank you, Claire. There it is, meow. Could make a slightly better rectangle there, meow. All right, now's the time to ask questions, meow. If there are no questions, we are moving on to the general house, which was actually our first house that we ever touched, meow. Here we go. If I take the antiderivative of f, meow. Does anyone? Oh, you've never seen this before. Arrow's seen it before.
Oh.
You remember what letter it turns into? Say again, meow.
Is it a capital F?
It is a capital F of x, and it's just kind of a weird notation that you just have to memorize. Capital F of x, and don't forget your
C.
constant of integration. When I'm going forward, don't forget your dinner. When I'm going backwards, don't forget your plus c. Yeah, it's the same question with two different answers depending on which direction we're going, meow. We're always going backwards now, so the answer to that question should always be c or your constant of integration.
Can we say don't forget your cake?
Yeah.
Cake.
Oh yeah, I like
I don't know about
Meow.
that.
You can totally say cake, meow, and I know that it's your constant of integration, meow. Okay, this one is kind of really, really important. It's called,
Double F capital.
this one is technically well, it's almost. It's very close to the fundamental theorem of calculus, which sounds important because it is. When you're going forwards, you're taking one realm of calculus, where you're taking derivatives, meow. You're talking about the slope of a line at a certain point, right, meow? This is the second realm of calculus, which for, I don't want to say hundreds of years, but for a long time, there were two different realms of calculus. The fundamental theorem of calculus connected these two fields, and now we all consider them just calculus, meow. But for a long time, they were totally different fields until we had the fundamental theorem of calculus that connected them into one field that we now know as just calculus, meow. So this is an important rule, and it's really simple. Anyone want to take a guess? If I take the derivative, but then go backwards, I'm left with what, meow? Just f of x, meow. But don't forget your
Plus C. Yeah.
plus c, meow. Yeah. Which seems kind of silly, and it's like, oh, obviously, if you go forwards and then you go backwards, you're left with what you began with. That, I mean, right here, notation makes sense when you get into the analytics and why that actually happens. Like, the slope of the line and the area underneath the curve, those are related. It's a hard field, meow. Anyway, if I go forwards twice and then backwards once, I'm left with what, meow?
F prime of X plus C.
F prime of x plus c, meow. Yeah, good job, guys, meow. General house is really, really easy going forwards and backwards, meow. Just add a prime or you take off a prime, and if you can't take off a prime, then you just go to a capital F. Meow, this is standard for the AP test. When you go backwards of F, they will always tell you, we define going backwards as capital F. They'll always do that, meow. Now you're just getting used to it, meow. You'll see it ahead of time before they even give it to you on the test, meow. Here we go. Antiderivatives of this polynomial. This is kind of like using the distributive property, meow. You distribute this antiderivative into both of these functions, meow. So I rewrite this thing as the antiderivative of 3x squared dx, meow, plus the antiderivative of 2x dx, meow. And then I take the antiderivative of them separately, meow. I realized that I printed out the notes and I only need them for that first 5 spots. I've never been looking at them. I guess I should check my work, meow. Indeed, yes. Oh, and the other thing that's kind of important to note here is the reason I can distribute it is because this is a power of 1 right here. Only when this is a power of 1 can you distribute, meow. If you have a power of 2, then you have to do trickier things, meow. And by trickier things, there's that poster up there that I will make you guys read after this lesson, which is going forwards, you apply one of these 3 rules. Going backward, you apply one of these thousands of rules and you might not still get the answer. Going backwards is hard, meow.
What now, meow?
It'll make sense after you get through this whole unit, meow.
That,
But especially now that I'm going to be teaching you guys BC calculus also, going backwards is going to be especially difficult because there's a going backwards product rule that I've never taught Arrow, and it's actually not that hard. It just took me like 2 years of college to figure it out. I can teach it to you guys in one lesson, meow. It is hard though, meow. It took me a while for me to wrap my head around anti-product rule, which is really called integration by parts, but we'll get there, meow. Anyway, here we go. Take the antiderivative. X to the power of 2 is going to go to 3x to the power of 3, meow. Again, divide down and I get what, meow? Divide by what, meow? 3, meow. Don't forget your constant of integration. And then we can say plus over here 2x to the power of what, meow? 2. Divide down by what, meow? 2. Don't forget your constant of integration, meow.
Two C's or
And
one C?
that's a great lead-in. Do we need 2 C's? The answer is no. You only need one constant of integration. You can just combine those. You can, here, this is what we normally do to be professional in calculus. We say, this is C1 meow. This is C2 meow. And if I combine C1 and C2, I define capital C with no numbers to be C1 plus C2. But of course, you can just totally ignore that and just say, okay, just only add one C meow. So our final answer is x to the power of 3 plus x to the power of 2 plus C meow.
It's been so long since I've had to draw the like integral symbol, you know?
I keep accidentally writing the F, you know,
Yeah.
like
Oh.
function F.
Interesting meow. Yeah, you'll get used to it. That concludes the lesson. Are there any questions? How do we feel about this lesson on 5? How well do you think you can go backwards like this stuff? Changing the forms, etc., etc. You know, I see a 4 meow, 3 meow, 4 meow, 4.5 meow. Cool, so that ends this lesson. I'll make you guys look at the poster now.